Hey guys, we're going to start lesson 7.1, and we actually already started talking about this before we were off on break, but it's a little bit of review from stuff we've done before. So we talked before, if we have this function, I'm just going to call it f of x. If we want to find the area under this function, okay, so this area right here, between those 2 points a and b, we use an integration. So we go from a to b of our function f of x. And we take the antiderivative and plug it in and solve from there. Now, let's say we also have another function. Put it here. We'll call this function g of x. We can do the same thing with that. We can find the area under g of x using the same thing. Now, what we want to focus on in 7.1 is how do we find the area in between these, okay, in between these two curves. And the way we're going to do that is very simply, we're going to find the area under f of x using this. So that's this entire area. And then we're going to subtract the area under g of x. And we can do that all in the same integral. Okay? So this is how to find the area between two curves. Okay? So how to find this red area between function f of x and function g of x is you go from a to b, those are your 2 points, and this is the top curve. It doesn't have to be a curve, obviously, it can be a line, minus the bottom curve. Okay, and that's basically it. We're going to do some example problems with that. The notes are obviously a little bit different because we're in my basement. Welcome to my basement, by the way. My handwriting is really bad when I do like the video lessons. Using the screenshot, and for the lessons that we're doing in chapter 7, you need to see my excellent handwriting, so that's why we're using the chalkboard. So the notes look a little bit different. What I would like you to do is follow along in your book because I'm going to be working through examples in your book. So this is, you know what, let's erase this, we don't need that part anymore. Okay, so this is example 1. From your book, and I have the book right here. I'm going to read it. It says, find the area of the region bounded by the graphs of y equals x squared plus 2. What else? Y equals negative x equals 0, and x equals 1. Okay, so we want to find the region bounded by all that stuff. And if you can't see because of the glare on the chalkboard, again, check your book. That's where this example is. So the first thing we want to do is graph this so we can get a good picture of what's going on. Y equals x squared plus 2 is a parabola shifted up 2. So it looks something like that. Y equals negative x, of course, is a line, the slope of negative 1. And x equals 0 is here, and x equals 1 is here, and it doesn't really matter all that much. We are looking for this area. Okay. So to do this, we're going to do the integral from our 2 points they told us in the problem are 0 and 1. Our top curve is the parabola, so x squared plus 2, minus our bottom curve is the negative x. And it looks like that. Can you see that okay? There's a little dead spot in my chalkboard. Try that again. Okay, top curve minus bottom curve. Now, before we do this, you may want to clean it up algebraically a little bit. So we get x squared, that negative is going to make that a plus x. And now we're going to take the antiderivative of this. So we get 1/3 x cubed plus 1/2, another dead spot. And that sound is my son throwing a tantrum upstairs over who knows what. All right, and we're going to evaluate from 1 to 0. So that means first we plug in 1. So we get 1/3 plus 1/2 plus 2. And then we subtract, we plug in 0. That's just going to be 0 all the way across. So we end up with 1/3 plus 1/2 plus 2. Let's see, if we really want to get common denominators, that's 2/6 and 3/6 and 12/6. So 17/6 for that answer. All right, I'm going to turn the page and we'll check out example number 2. We'll do example 2 over here, maybe. All right. Example number 2 says, find the area of the region bounded by the graphs of 2 minus x squared and y equals x. So f of x is 2 minus x squared, and g of x is just x. Did I get that right? Yes, okay. This one's a little bit different because they gave us a little bit less information, but it's still going to be pretty similar. First, we're going to graph it. This is a parabola that is going down and is shifted up 2. So it looks like this. And then we have y equals x, of course. Now, we are looking for this area between. They did not tell us what those 2 points are. Okay, we don't know what these intersection points are, so we have to find them ourselves algebraically. We're just going to do that by setting these 2 equal to each other. Okay, we need to find where those intersection points are. I'm going to move everything to the right side of the equation. I'm going to factor it. And we find that x is -2 and 1. So those are these 2 points, -2 and 1. So now when I set up my integral, I'm going from -2 to 1. The top curve is the parabola. So 2 minus x squared. And the bottom curve is just the line. And maybe we want to clean that up before we take the antiderivative of it. That's going to give us -x squared minus x plus 2. And then we'll take the antiderivative of that, which is -1/3 x cubed minus 1/2 x squared plus 2x. And we're evaluating from 1 to, no, not -1, to -2. Okay. First, we're going to plug in 1 into all of this. So we'll get -1/3 minus 1/2 plus 2. And then minus, we're going to plug in -2. That's a lot of work. 8/3 minus 2 minus 4. And I'm going to, since I'm running out of chalkboard space, check with what the book says. The final answer is 9/2. So if you finish out the algebra there. Okay, so that's just the basics of it. We'll get a little bit more complex in the next videos.